So again, thank you guys for coming. We know there's a competing event. It's a huge deal, and thank you for coming today. So our team is quite small. It'll be me and Chris, and let's get started. So this is the agenda for today. We're going to give a background on what we presented last year and the alternative to use Selenium WebDriver Promise Manager, and by using the latest version of JavaScript using async await and new page objects, extending Mocha, and using type-safe JavaScript with Facebook's flow type library. So if you guys know, JavaScript is very fast, and you can make errors pretty fast too as well. It's not type-safe like Java or other stuff. But with Facebook's flow type, we managed to get annotations inside JavaScript and correct, do static analysis and compilation before we check in code. Robust visual diffs, we'll be touching on some of those. And then what's next? So back in 2015, we started looking at Node.js for our end-to-end functional testing framework. The reason is we kept Node.js adoption in mind. As you can see, there's hacker vector. A lot of companies are moving to full stack. We wanted to share code with full stack developers, so we talk in the same lingo. The slides are here for if you guys weren't here last year or didn't come to that session. So this is the background to that. And this is the reason why we chose Node.js, because as you can see, the whole stack writes JavaScript and Node.js. And we have a few microservices in Go and Python as well. So this is the stack of what we presented last year. We use Mocha and Applitools, and then Co for the UI framework. And for the backend framework, we use Co requests, Mocha, and then Shy. This is a background. You see what it looks like now. This is kind of like a preface of what the architecture looks like. Sorry, my bad. This is to confirm the choice we made for our libraries is Selenium WebDriver. This is Selenium WebDriver's usage. The official library is on NPM for 1 year. As you see, we are on the winning horse, and adoption has been the most ever. So it's always good to look back and see whether the tools you choose are actually the main adoption tools that everybody else is using in the market. The same with Mocha as well. The competitor is Karma, Jasmine, and Cucumber, but the adoption rate of Mocha has also been increasing very rapidly for the past year. So before I go on, who here knows JavaScript? Awesome. Who here doesn't know JavaScript? OK, we'll bring you guys up to speed. So what we presented last year looks like this. It heavily relies on Selenium WebDriver's control flow. If you don't use this, you'll be writing really ugly code like that. So that's a dot then there is a promise in JavaScript. That's how you synchronize code and make framing and ordering of execution top down, so it doesn't fire like 5 threads at the same time. So using the promise manager control flow allows you to write this instead of that. So this is where we are right now. And the core, I think even right now with the latest Selenium 3, the WebDriver API is still built on control flows. So with that, we made JavaScript look like Java the past year. But this talk is to present other alternatives into writing code like cleanly like Java, but still be in the confinements of Node.js. This is how you use the promise manager. So you require a test variable from the official libraries under the package testing, and you override it in the Mocha it function. And all these guys gets queued up, so it's almost like a compiler to run commands line by line. It's top-down like Java. So that's what it looks like before. But there are caveats. So because you're locked into the promise wrapper, if you want to switch context to call like a REST API call that's built on top of other libraries, you need to do some context switching, and you need to call a flow execute function, and then call like a generator call, like a yield call, and then and so this here is like native JavaScript within generator, and then the rest is Selenium control flows. So I want you to pay attention to the context switching stuff, because we'll be hammering on a lot of these going forward. I'll pass it on to Chris.
Thanks, Mek. Another quick, just like pulse check. Who, if anyone here, is actually using Node within production for test automation? Got some people, all right. I'm going to grab the bottom of the mic so you can hear me and I'm not overly distorted. Okay, great, we're on the right track. So there are a couple of us here. So let's just step back and think about some of the problems, particularly with test automation, right? We kind of have like two opposing, impossible, like what is it, unmovable object and then a unstoppable force, right? Basically what happens is that everything within WebDriver is async. Every call to the Selenium API is an asynchronous action, but when we write test automation and browser automation, everything, basically, not everything, but 99% of what we want to do is from top to bottom synchronous. So like, we're always battling, especially in browser automation, to make desync or like desynchronous code out of asynchronous actions. And the solution to that for WebDriver has been this idea of you wrap everything in your tests around promise, like this promise wrapper, right? And it'll take care of the rest for you. As Mek mentioned, there are a couple problems behind that. Here's kind of what we've gotten on our side from using JavaScript with Selenium WebDriver, and I'm certain those of you who don't use JavaScript encounter some of the same issues. The good stuff is that like we're able to particularly work very closely with other developers on our team. The fact that JavaScript is, this might be controversial, but close enough to a universal programming language for a lot of people who are learning these days is fantastic. That means that we can actually bring in developers from outside our test automation team to come in and get involved with us and write tests. And kind of the line between test automation and like, say, someone who's working on front end is very, very blurry. That's a good thing for teams. It encourages collaboration. On top of that, JavaScript is an awesome open source community. I'll get into that a little bit more. But people are coming up with fantastic solutions to problems. You might imagine it's just to be the front end, but when it comes to back end services, or in particular test automation, people are doing really amazing stuff. And it's fun. It's a lot of fun. Some people don't like the spaghetti code, but it's a lot of fun. All right, but there's bad stuff, right? This promise manager, is anyone here who works on Selenium WebDriver for JavaScript? Okay, I just want to make sure I don't hurt anyone's feelings. There's some problems with it, right? And one thing in particular is that it's not agnostic, and the code and the tests are not very portable. On top of that, like iteration through, say, selecting a set of elements and iterating through them to get their text. Hello, I'm still here. Okay, iterating through elements to get text or to press buttons, a set of buttons can be really, really difficult. You can get really deep down a sort of pyramid of doom, as we'll see in a bit. On top of that, as Mek showed, if you're doing WebDriver-based actions and non-WebDriver-based actions the same test, it can get really confusing. You got to go back and forth between them, and I'll show an example of that as well. So here's kind of an ugly version of that. These are the 4 criteria I think really encapsulate and really show like what are the 4 things we really want to care about in writing test cases in browser automation. Are they readable? Do they have a flat structure? Can anyone look at it and understand what's going on? Are they free of context? Are they portable to other test runners or other, even like, other frameworks, right? Are they asynchronous? Are they readable from top to bottom? You see the actions in order. And in the case of JavaScript, are they in line with the standards of the language? ECMA being the sort of standard setting committee, this dark shadowy committee that decides like what JavaScript standard is. Are they really in line with that? So we noticed with WebDriver and this kind of promise wrapper library that there's some problems. You see here, we have a page object method that's trying to get messages from a page. When we try to like iterate through a set of elements, we're having to create a new control flow context, and like it just sucks. Like we have to do that kind of randomly. On top of that, it's not very clear Well, I'll ask this question to the crowd. Like, is this function of the driver asynchronous or synchronous? Anyone know? Find elements. Is it asynchronous function call or synchronous? Not all at once. All right, async, right? Everything is async with the WebDriver. But it's not really clear here. So if I had a developer coming and looking at this, they'd be like, what the hell? There's not really anything that shows us like that particular is an asynchronous thing. It's just all handled by this wrapper. It can be very confusing. Anyone here have run into similar issues with their WebDriver libraries? Bueller. We're the only ones? I doubt that. Come on. Here's another case where we have to do a lot of context switching, and it can get really annoying. And then there's like really big Pyramid of Doom type stuff where we're having to dig deeper, in this case, dig deeper and deeper into a table and try to find cells within rows within a table. And this is, I mean, it's a combination of like bad code writing on our side and also like having to deal with all of this wrapper stuff. So we're like, basically, I don't know if y'all can see this clearly, we're having to create new control flow context. It's just nutso, right? Don't do this. Don't do this. All right. So we had a lot of training wheels on, and what we wanted to do is like, you know, knock those things off and become crotch rocket racers, all right? So this is a really great feature that's been cooked. Can you guys hear me okay? Okay. This is a really great feature that has been cooked. Hello. Psh. Kind of works. This is a really great feature that's been cooked into JavaScript as of late. It's called async await. Has anyone here heard of that? The JavaScript people raised their hand. Okay, cool. So what's going on in JavaScript is that because a lot of people are using it, a lot of people have realized it needs to be an actual programming language, and so they started to write really great new standards for it, and new specifications are coming out, you know, month after month by this committee. One of the specifications that's out is called async await. What it is basically a way to define functions that are deliberately, explicitly asynchronous and can await values returned from promises. Who here is like familiar and really comfortable with the idea of promises? So I can maybe explain that. Okay, I can explain that a little bit. So basically, a promise is a value that's returned from a function that's asynchronous, and it resolves eventually to the value you're looking for. So say something like get text. You grab an element and you go get its text. What's going to be returned from that in JavaScript is what they call a promise. And then you have to basically chain a function onto that to then do things when that value, that text, is ready. We'll see a dot then chaining in just a second. But what this does is different, and I think makes much more sense to maybe a non-JavaScript person, is now we can just wait for these asynchronous values to arrive and grab them, pause execution of the function, and just hold on to them until we need them. So let's take a look at what that looks like. This foo, let's say foo is like a WebDriver method, right? So it's called and it returns a promise, and that eventually returns some sort of value, a string. In JavaScript, what we would have to do, and what we've been doing, is going ahead and chaining a then onto the promise return, and then logging the value that eventually will get delivered by the promise once it resolves. Now, this is beautiful, right? We can actually pause execution, await for the value returned by foo, which is a promise, wait for that to resolve, grab it as a variable, and then do what we want with it. This has made our lives incredibly easy, and we've been able to actually bring that into our tests. So this is what the difference looks like, some of these ugly examples. It's fitting our 4 criteria. It's flattening our code, It's making it context-free because we're taking it outside of the promise manager that was provided by WebDriver, and it's actually in line with standards of JavaScript. And I see you taking pictures. We'll definitely have these slides available online, so don't worry. You can take pictures if you want. Yeah, no problem. You see here like the case where we have to actually create a promise and fulfill it and then return the promise at the end of the function. It's just a little dirty, right? Now we can just create these async functions. Here's another case. So this is where I think it gets really special. I think it's really nice when tests, browser automation tests, are completely unaware of the existence of like Selenium and WebDriver, or try to get them kind of abstract them away from that. So in this case, this old example that we had, we're wrapping it in this test.it, which is the Selenium WebDriver promise manager wrapper. And then we're having to create all of these new flow contexts. It's basically a way of like syncing up different actions, right? It's quite silly. If we take it out of that wrapper, now I got this, look at this, flat, right? On top of that, we are able to leave the promise manager. We don't have to create new like control flows or like execution frames. And we have this nice, beautiful, like in line with JavaScript standards syntax. And on top of that, we're very aware of which calls, this being like a REST API client that's creating a job in the back end, which calls are asynchronous because we're putting a little await keyword in front of it. Any questions about that syntax or what this looks like or how it would look like in a test? Everyone's got it? Cool. All right, in the memory banks. Quick look at what this will look like. I actually created a small example repo of how to actually construct this, and I hope it highlights like how easy it is to get up and going this way, and then to write tests this way. We use something called Babel. Anyone heard of it? JavaScript people heard of it? Yeah, there we go. Okay, cool. So what that is basically a compiler that you can put into your code base, and it will transform based on what you want it to. Transform any new JavaScript features like async await that aren't yet in Node or in your browser, and actually compile it to like compatible code. So Node, for example, doesn't have async await currently. I think it will be in like Node 7. So what we have to do is compile it to like non-async await code, and Babel is a tool that allows us to do that. So let's just take a look at what this would look like. All right. So basically what I have here is, this is going to be fun to like hold the mic and type at the same time. I wonder how I can do this. I wish I had 3 hands. All right. Thank you, Mek. So basically, no, it's just stuff. So basically what we have is like a few dependencies, just Selenium and Babel, right? And Mocha, which is our test runner. And we're able to hook up Babel into Mocha. What this does is it compiles our code before it runs in Mocha. Mocha being the kind of test structure and runner. It's really easy to do. So let's see what this looks like. If you were here for Mek's last talk, he mentioned a lot about like page objects. Sorry? Yes. Enhance, enhance, enhance. All right. He talked about page objects. These are representations of a given web page. So in this case, this is actually the homepage of Sauce Labs, represented in a really simple way. It's just the selectors for the title, as well as like a search button. We then inside of these create asynchronous functions that are the given actions. So maybe get the title text, or enter some text into the search bar and click submit. We're able to essentially call and await different asynchronous driver functions in order to get this done. It's really clean, it makes sense, and any dev who is not regularly working in browser automation, I think, can look at this code and really understand what's going on quite easily. With a quick look at the acceptance test, so this is like the basic test. I'll run it real quick because it's fun to watch. It's kind of fun to watch like browser automation test happen and the window pop up and get clicked, right? Does anyone get warm fuzzies from that like I do? Okay, cool. So that like in this case, these tests are really simple. We've put all the logic of the driver inside of these page objects. This is all available on GitHub, by the way. We'll give out the link. And then able to just call these very simple methods that do what we want to do. So this first case, just make sure the home page is loaded. Go to saucelabs.com, make sure the home page is loaded, get the title, and then assert whether or not it's correct, right? Very flat. Same thing with this. Search for a term, and then quit. Like that's super straightforward, and I think anyone who is on your team will be able to contribute to this and write tests quite easily. All right, now for the actual show. Just because I want to do it. Let's see, I think it's under. All right. npm test. Come on, Chrome. I actually don't know if I started up Selenium, so we'll see if this actually works. Yeah, we're good. So one thing you notice is that, there's the page. All right, Sauce Labs loads. It's going to search for Airware. And it made sure that the text said search results for Airware. So it's really that easy to write tests, and now we got our 2 passing. So I hope that's a very clear example of how easy, once you get it set up, how easy this sort of idiom can help you write tests in JavaScript. I'm curious to talk to anyone after the talk about how that structure compares to what they're doing in other languages and with other WebDrivers. But to me, that seems incredibly simple. So this is what we had last year, and because of our changes, especially in this regard, we're able to kind of merge together our back-end and front-end clients, so both our page objects and any clients that are calling REST API, and merge them into a more cohesive framework. So there's some differences here. I won't get into the nitty-gritty on that, but our level of dependency, especially on Selenium WebDriver, has gone way down, and it's helped us significantly. There are some cons. As with promises, sometimes basically every time you have to be very careful about error handling, and of course that's very important in browser automation. At least in Mocha, we're able to handle errors well using this paradigm, but in cases where we're scripting other things, we have to basically explicitly try catch within the function, the main function that's being called. There's some really good examples of that online. This second one, I guess, might not be a con. It's more of a pro-con. But now devs really have to understand promises. Since that's kind of the underlying thing here, any promise can be awaited. Now everyone's going to really have to understand the concepts behind that. But I think if you have JavaScript developers who don't understand promises, you might be in bigger trouble. On top of that, this is something we encountered. Adopting this is really all or nothing. If you're not really dealing with async directly in your code or using callbacks, this is going to be a hell of a refactor. It can be, yeah. All I can say is it wasn't fun refactoring. It was fun when it was done. Some of the optimizations of the promise wrapper that was provided by Selenium are gone. I mean, they were writing it to make sure that it could move really fast, queue up tasks for the WebDriver, but now we're outside of it. So we've seen some differences, sometimes it's faster, sometimes it's slower. It depends on what type of test is being run. And then on top of it, you got to add a wait in front of every call. I think that's also a good thing because now you're very sure, okay, this is a function that is asynchronous. This one is not. Cool. So the bottom line is basically, it's really great if you are starting with WebDriver or with Selenium for the first time, I advise you to use JavaScript. I advise you to try out this paradigm. It's incredibly useful. The glove really fits. It's almost as if async await was designed for browser automation, although I don't think that's what any of the spec writers would ever admit. On top of that, refactoring can be really cumbersome, but I think it's actually worth it, depending on the size of, how many tests you have. You're really, at the end of the day, simplifying your tests. That's a really key thing for you, your team, any other developers, any managers. You really want to get to the point where people can read your tests legibly, even if they're not an engineer. And this is a good way to get there. All right. I'm going to go over really quickly about some other stuff, a little bit unrelated, but I think it kind of shows some more of the strength of JavaScript in MochaJS. Let's take a step back, actually, and ask a philosophical question about talking to developers throughout your team, people who aren't doing browser automation. How do you deliver your results to them? And what type of information do you prioritize? What we did at Airware is we stepped back and we talked to other devs on the team and said, okay, how can we get you 1 or 2 clicks away from knowing the information you need to know? There's so much information that comes out of these tests, right? You can go and peer through the build log, but there are a couple important things that maybe a front-end developer would like to see or a DevOps person would like to see. You should be asking these questions to your team and figuring this out. Things that we found at Airware were that people really want to see failures first. That makes sense. They want to see the failures. They don't really care about the successful tests. They want to understand the difference between flakiness and failure. I'm certain we all have dealt with that in browser automation, right? Yeah. But really what's important is to make sure that's reported accurately to the rest of your team. They want to see clear assertion messaging. If it says 1 should equal 2, no one knows what the hell that means unless you give it context. So making sure that failures are accompanied with a sort of context giving assertion message. And then these are particular to browser automation in Sauce Labs as well. Sauce Labs is really great for this. Screenshots of the failure and video of the entire test as it's run. So we use this information, just cook up with Mocha and JavaScript, a very simple reporter. Don't laugh because it's quite rudimentary, right? But we're able to deliver. I guess there's a beauty in the simplicity of it because we're able to deliver only the information that really matters to the rest of our engineering team. So here's an example of a failure. I might send this over to a front-end guy, right? Except this case is actually a flaky test, so I would actually look at it myself and fix it. But notice we're giving the feature name and the task of the project, the error as it happened, a little bit of the stack trace, right? And then a screenshot and a link to just quickly download a flash file of the video of that test as recorded by Sauce Labs. If I give this to somebody for a test failure, they're 1 or 2 clicks away from understanding the problem, and I don't have to go out and fish through a build log or a bunch of stack traces to figure out what's wrong. As ugly as this could be, it's very easy to make, especially in these test runners, and you're providing simplicity to the rest of your team. Cool. The other really great thing with JavaScript and how it's so flexible is parallel tests. You can very easily spawn new processes, and browser tests take a long time, right? And who here actually runs at their company, runs their browser automation in parallel? Got a couple. Cool. So you should do it because it's really long. The hard part, yeah, I mean, it could take 2.5 hours if you write enough tests. Stupid. The hard part is making sure that everything's reported properly and that we're cobbling all this together. And this is actually a screenshot. So we've been using this library. We had a couple of our own solutions that didn't quite fit the bill. But hey, shout out to the JavaScript community. People are writing really great solutions to this problem. This is a parallel test library. We're able to run it within Sauce Labs and cut our time by 60% by running a couple of different tests in parallel. And it all shows up in Sauce Labs beautifully. So I really encourage you to, no matter what language you're using or library, go ahead and search out what's available in parallel. Although I'll say the active community in this, in testing, is definitely JavaScript. All right, cool. So the bottom line of that is, you want to have something that's really scalable, that delivers what other devs on your team want. You want to listen to that and respond to that. And I'll argue that JavaScript is really a great place for that, like a great method or vehicle for that. But it can happen in any language. So you need to basically expand specifically to what the context of your company needs. And you should always keep an eye out for the open source community and seeing what solutions other people are bringing forward. Great. All right, one more thing. I know I've been up here a while, and I know you guys all want to see like if Donald Trump said something crazy in the last hour and a half. Cool. So I hear it. A murmur in the crowd, probably, like JavaScript. There's some downsides, like the Java people are probably wincing because there's not types. There isn't strong typing in JavaScript. Well, there are ways of doing that, right? All of the things that you hate about JavaScript can be fixed through a library or some sort of open source solution. In our case, we really wanted our code to be type safe and make sure that we, we're writing code, tests that work, because no one's watching the watchers, right? We have to watch ourselves. So we use this library that was put out by Facebook called Flow, and basically we're able to slowly annotate our tests and all of our functions to make sure that when we're writing tests, as we're writing them, we know if we're writing them wrong. It's been incredibly helpful. It's sped up our development. Let's see how much time we got. I don't want to talk for too long. Okay, cool. So let me show you a really quick example of that. So what we ended up doing is, and this was not fun either, but it's now out there if you all want to use it. We ended up writing, let's see. Well, it is out there, I promise. It's basically a giant definitions file for WebDriver methods, right? And it has annotations, so we'll say this method is within WebDriver. The driver can call .get, and that should only take one parameter, which is a string, right? And it will return a prompt. What that does for us is that when we're writing stuff let's say within this test I'm screwing around. Let me get down to a place where I'm in test context. You guys are seeing proprietary Airware tests. Don't share it. All right. So say I'm writing a test and I want to call driver.get something. Looks like this is the fun of demos. So basically what I'm doing right now is that Atom, which is this text editor, has a plugin. It kicks up this server which statically analyzes my code, and it checks against the definitions file. So when I actually call driver, I'm able to see what methods can be called, and it will yell at me if I call the wrong thing or if I pass in the wrong parameter. Yeah. It doesn't seem to be working right now. But basically now, if I were to call driver.get and pass in a number into here, oh, perfect. You guys can't see this down here, but on the bottom it says, basically expected a string, right? So it's yelling at me, which is fantastic. And then if I were to run flow, npm run flow. Okay, so that's actually a different error. This is not really proving my point. I need to kick up the server again. The point is that this is really fantastic. I actually, as I'm writing my tests, can realize if I'm effing up or not. I hope you all are doing that. And who here is linting their code? Why isn't everyone raising their hand? Oh my God. Okay, so that's the first step. Set up a linter, whatever language you're using, and lint your code, because that's incredibly important. And pretty much every modern text editor or like IDE provides like plugins or extensions that will lint your code in real time. You should be doing it. Because how embarrassing would it be if we're writing tests to check other people's codes and our code is not standard, right? Like that sucks. We should be holding ourselves the same standard as people who are working on features. So that's my soapbox moment of the night. Thank you. Okay, I'm going to pass it back to Mek. He's going to show one more really cool feature that we've been working on this year.
Awesome. Thanks, Chris. Cool. So any of you guys here use visual diffs at all to compare screenshots? Cool. You guys use Applitools or you guys roll your own lexically? Awesome. Okay, cool. So we figured out a better way to supplement Applitools and by adding robust visual diffs. And the same as Selenium WebDriver, long tests are flaky. Same thing with visual screenshots. If you don't care, just shove in like a JPEG and you hope it's going to stay green. It's never going to stay green. You have to carefully carve what you verify and what you can stabilize. So this is a flaky Applitools test. So some of these maps actually fail. This is actually a screen cap of Applitools that we use. So the pink areas are the areas that doesn't match and are flaky, non-deterministic. So what we try to do is, how do we make this test more stable? And if you guys have heard of the test pyramid, the big tests, end-to-end tests are the top. They are high cost, right? They take longer to run. They should be in lower numbers than the rest of the tests. The medium tests, like the integration tests, are like the REST API tests, are medium size. They should be, they can be more in numbers, but then the size is actually bigger than, smaller than the big tests. And the small tests are the unit tests, which is down below. You should have a lot of unit tests. They run fast. They have fast feedback, but you should have a lot of them. So that's the goal. So yes. So for time, the higher you go in the pyramid, the longer time it takes to get feedback. The lower you come down in the pyramid, the shorter the time it takes to get feedback. Same with coverage. Selenium and end-to-end tests are long-running tests, right? More coverage. So, but you can supplement that with unit tests, which are smaller tests. They have less coverage, but you should add more of them. So we took this concept to heart, and we applied it. Oh, before we move on. So Google, I'm not going to go dive into details, but the Google testing team recommends this ratio, 70% unit tests, 70% unit tests, 20% integration tests, and 10% end-to-end tests. The ideal mix would be different for each team, but try to stick with that ratio if you can. So we took this concept to heart, and we made our own pyramid for visual diffs as well. On the left-hand side, that's the whole engineering organization test pyramid. You have the unit test for the whole organization, you have integration tests, and you have big end-to-end tests. When you zoom in to the upper half of the engineering pyramid, you have the QA test pyramid, where you have visual tests, which is the top, UI, browser, automation, Selenium tests, which is in the middle, and the bottom is your REST API integration tests and end-to-end tests. And we went even further by breaking down those visual tests into 2 layers. The top one is the whole browser screenshot, where you take the whole screenshot of the browser. And the lower pyramid is back-end image diffs, where you do image diffs without touching the browser. You do this via command line, and Applitools has a tool to do that. So the key here is treat visual diffs the same way as how you would treat a test pyramid. Bigger tests, end-to-end tests should be in small numbers, and smaller back-end image diffs should be in higher numbers. That's how you make your pyramid solid and have robust image visual diffs. So these are the links. This is Applitools library. So this tool is just essentially uploading a PNG format. You can do this with file streaming. You can stream it directly from your API. You need help from developers to have an API to provide you with this. Or you can save it as a PNG and just upload the PNG to Applitools, and they will do the visualization validation for you. The more info is there, and special thanks for Liran at Applitools helping me out here. So this is what a visual diff test pyramid looks like. The upper end-to-end test is like 3 screenshots at the full browser resolution and size. The lower one is, these are all map tiles. So what you see here in the ortho mosaic is actually this guy. But we actually pull this rendering back from the backend, and we don't touch the browser at all. This is like a color relief tile that we pull from the backend as well that is represented in the layers in the full map view. And this is like a small tile that we render in the browser, but we pull them out as smaller size tests, and we run them as part of the test pyramid for visual diffs. So that's how we try to make our visual diff tests more robust. So what's next? I think this is the last section of our slides, correct? Yeah, cool. So yeah, what's next on our plate? So I came across this talk by Denali at Uber. She presented at this meetup, I think last year. The title of the talk was "Testing in 2020" and how you make testing faster and get faster feedback. This is one of the slides that we really took to heart. It's called Important Attributes of CI and CD systems, being continuous integration and delivery. I want to touch on these 2 points here where cutting edge CI has to be fast, but it has to have trustworthy results. Tests that do not add value are removed immediately. Like flaky tests, we quarantine them and remove them immediately. Have the privilege and not the right to run in CI. The second one is what we're going to talk about today is trend analysis. So you run tests every day. You run like batch tests, smoke tests via cron jobs on staging and pre-prod. You generate a lot of metadata from your tests, test results. And if you collect them over time, you can do really interesting stuff. So it's called, that's where we're going to drill into a test trend analysis. And if you are really good at this, you can tell over time, is your feature ready to ship or not? So this is our dashboard that's working in progress. So this tells the trend of staging right now. It's almost like the health of the cloud, whether how many tests have been passing and failing, what's the trend of the pass and failure. And the end goal for this is devs can deploy into production 100 times, how many times as they want, as long as this is green. And our goal is to get this to turn green. Once we have that, we will lock staging down. And anything that comes in and turns this into orange or red, we will have to halt any merges into master and have them fix bugs. So that's the end goal. But the key here is data. Big data is applicable to everything, including test result as well. And I think we have our intern here that was spearheading this effort before, but yeah, he started that. So thank you for your contribution. This is what it is right now, and then we will probably have another meetup session to drill down detail once this is ready. The next thing I want to talk about, which is what we're doing right now, is requiring testability as a product requirement. You can't automate what you can't get your hands on. So what we do at Airware is we closely collaborate with the front-end teams, and we both write in JavaScript now, so everything is easy. The front-end guys actually surface IDs and attributes in the DOM for us to grab. For this example, we have the UUIDs of the objects, so we can actually, from the DOM, scrape it and then get the ID and make a backend call so we can verify that the data in the front end and back end is exactly the same. And there are attributes that are surfaced as well, like if we verify that the image name here is the same, there's actually a data attribute that comes from the back end in the DOM as well. So we don't have to make a backend call to verify it. In this case, we just compare what's ever in the DOM and then what's ever rendered via Selenium. So that helps a lot. And we're looking forward to do more of these. So yes, testability as a product requirement is very important if you want to move fast. I think that's it. So thanks to Chris and Sauce Labs. All the links is on GitHub. Feel free to look at them, all the examples. We have also the async await example and also the flow type interfaces. You can just plug this in, install flow from Facebook, and start static analysis on your code base immediately with WebDriver and all the goodies of Mocha. With that, thank you, and we'll take questions. Any questions? The visual diff, yes? Oh, Applitools. Oh, so yeah, so we have, I think, someone in the audience. Kerr, is it here? Yes, so he works at Applitools, so you can talk to him. But we've been using them very extensively to do our visual diff tests. We don't roll on tools because it takes too much time to write and maintain. So we just outsource it to a cloud provider, which helps a lot. Yes? So, Chris, you want to take that?
Sure. Yeah. There are a lot of problems. I've been traveling the 7 seas to find a really good way to debug Node using like Chrome DevTools. Had trouble with Node Inspector, which is probably the most famous one. There's one that called Iron Node that I started using that had a really good set of tools for debugging async stuff that I've started to find useful, but the search is still out there. I think it can be really difficult. I'm loath to admit that sometimes I simply just log to the console to try to figure out what the problem is, because setting some of these things up can be very hard with async.
So Chris and I disagree on some tools. So he's the Atom crowd. I'm the WebStorm crowd. So it's paid, so it's the downside of WebStorm. But right. So WebStorm, you can actually click debug, and there's a breakpoint you can actually run. But yeah, you need to pay for it. So that's the downside. But
And
WebStorm is able to debug.
I'm stubborn too.
Nice.
Cool. Any more questions? I think we have some time left.
Oh boy, I wrote it. Yeah, so I was asked writing the interface file, or like the definitions file for WebDriver. I wish it was generated normally. I did, to be fair. So TypeScript is another really good, it's like a superset of JavaScript, and they have a admittedly better community for type definitions of libraries. They had a WebDriver definitions file, but I had to go through that and convert it over to Flow. But now it's available, so no one has to do it again if you guys want to start using it. So it's out there on GitHub.
Yeah, we don't use TypeScript because I don't think they support async await yet. So we chose async await, so we have to roll our own flow type definitions. But yeah, everything is there. You can download it and filebox or fork it. Cool.
Same for Mocha and Chai. We put that all out there. Wrote our own definitions files for those. So as long as you drop them into your project and install Flow, you should be able to statically type against those libraries.
Any more questions? Yes.
Is anyone currently using your guys' tech stack or fork that, and do you know if they're using it in their test automation journey?
We don't know as of yet. So Dave Haeffner, if you guys heard of his name, so he wrote the JavaScript guide for Selenium. He actually quoted our work last year using the promise manager. So I have a to-do list to get back to him to give him this new recipe. So I think there's a few, but we don't know for sure. Yeah, more to come. Cool, awesome, guys. So thank you again for Sauce Labs. And recording and slides will be available.